Hello everyone, welcome to mkmathss. I am Karthik Mansali. So if you not subscribed to my YouTube channel, please do subscribe and also like the videos so that the YouTube algorithm just larger audience. So in last video we have discussed about a transitive relation, and it is a quite confusing and quite difficult to understand the definition because it has so many definitions. Transitive relation and not transitive relation, and it has another definition also which we say vacuously true. By with the help of vacuously true concept, we define a transitive relation. So there are so many examples to confuse that definition. So there are two three definitions are there. In previous video I have explained. If you not watched that video, please check my description. I have mentioned that definition of a transitive relation. I have explained in very detailed way. All type of definitions I have covered there. After watching that definition, now watch this example so that you will get a clarity about a transitive relation. Because to understand a transitive relation, we have to understand the definition as well as an example. If we combine both the definition and examples, then only the transitive relation will be easy. Otherwise there is a little bit confusion about a transitive relation, because the definition itself makes us a confusion. But when we understand the examples, then it will become a more easy to understand. Yeah. So in this video, let us understand and let us understand the definition with the help of examples so that we get a clarity without any confusion. Okay, let's start with the example. So in all previous videos I have explained about the types of relation: reflexive, symmetric, universal, empty relation. I have considered the set A equals to 1 2 3. So here also I am considering the same set A equals to 1 2 3 and creating a relation from this set A. So now we have to check the relation R is transitive or not transitive. Okay, so now let us consider relation R1. So this is a relation R1. So in this relation I have 1 comma 1, 2 comma 2, okay, 3 comma 3. 3 comma 3. I have considered a relation R1. In relation R1 we have three ordered pairs: 1 comma 1, 2 comma 2 and 3 comma 3. So these ordered pairs are related to itself only. Okay, so first let us understand every type of example now, every type of relation. So in previous videos we have discussed reflexive relation. So let us check this R1 is a reflexive relation or not reflexive relation. So reflexive relation is nothing but here 1 comma 1 and 2 comma 2 and 3 comma 3, which are all belong to R1. Then this R1 is reflexive. R1 is reflexive, so there is no problem. So when it comes to symmetric, 1 comma 1, and if we reverse the 1 comma 1, 1 comma 1 is also there. If we reverse the 2 comma 2, so 2 comma 2 is also present in R1. Okay, so 3 comma 3, if we reverse the 3 comma 3, then same 3 comma 3 will come. So 3 comma 3 will also present in R1. So this is nothing but symmetric relation. Symmetric relation. Okay, so reflexive relation, symmetric relation, very easy to find by observing the relation R. But when it comes to transitive relation, see here. So transitive relation definition says if A comma B belongs to R and we have, there should be a pair now, B comma A is also belongs to R, then A comma C also belongs to R. If A comma C also belongs to R, then it is a transitive relation. So now let us check for this R, this R1. Now I consider a 1 comma 1, 1 comma 1 and find the pair which starts with the 1. Here we have to find the pair. Here we have to find the pair which starts with the 1. So starts with the 1 means 1 comma 1 only itself. If you check in R, there is only 1 comma 1 is the only ordered pair which starts with 1. So I consider 2 times. So 1 comma 1, and we have to consider again it should start with 1. See here A comma B, and again it should start with B. Again we have to consider another order pair, it should start with B. So here we call it as a pairs. So A comma B and B comma C. We have to consider B comma C. So A comma B and B comma C. So it means for A comma B, B comma C is a pair. So here 1 comma 1, 1 comma 1 is a pair. So there is no other element which starts, there is no other order pair or element which starts from 1. So I have considered 1 comma 1 itself. So if we compare from first and last, so these two belongs to R1, implies if we compare first and last, then again we get a 1 comma 1 which is belongs to R1. So it is satisfying the definition. Still we can't say it is a transitive, because we have to check each and every element, each and every ordered pair of R1. So if we check each and every ordered pair of R1, if it satisfies each and every ordered pair of R1 this transitive relation definition, then we can say that it is a transitive relation. When definition satisfies for each and every ordered pair of R1, not for any one of the ordered pair, should satisfy each and every pair of ordered pair. Okay, so now again I consider 2 comma 2. So 2 comma 2, now I check for the which starts with 2. Again I am finding order pair which starts with 2, because I have considered 2 comma 2. Here the relation ended with 2, again it has to start with 2. So if I check which element is starting with 2, means there is only one ordered pair 2 comma 2. So again I am considering this 2 comma 2. So these two are belongs to R1, implies then I am verifying that first and last. Here first and last is nothing but again 2 comma 2. Again it repeatedly came 2 comma 2. So here we can observe in R1 2 comma 2 is present. So we can write here 2 comma 2 which is present in R1. Now we can't decide it is a transitive relation, because there is another order pair is remaining. We have to verify for that also. So again we have to take 3 comma 3. So here 3 is related to 3 and it is ended with 3. So again we have to start with 3. Again we have to start with 3. We have to consider we have to find a pair which starts with 3. There is only one pair, there is only one order pair 3 comma 3 itself. So again I am considering same 3 comma 3. So here first and last, if we consider first and last, so these two are belongs to R1. If I consider first and last, again we got 3 comma 3. So 3 comma 3 is obviously present in R1. Then now we can define, therefore R1 is transitive. R1 is transitive. Now we can define R1 is transitive. We have to verify this definition. Each and every ordered pair in given relation. Okay, if each and every ordered pair in given relation satisfies this definition, then obviously we can say it as a transitive relation. Okay, so let us check for another example. Let us consider another example. We have considered A equals to 1 2 3. Okay, 1 2 3. I have written here A value 1 2 3 set. So R2, I am considering it as a R2 now. So here 1 comma 1. Okay, 2 comma 2, 3 comma 3, 1 comma 2, 2 comma 1. Okay, I close the relation R here. So I have considered a R2. This is a new relation. So in this new relation we have a ordered pair 1 comma 1, ordered pair 1 comma 2, ordered pair 1 comma 3, and ordered pair 1 comma 2, and ordered pair 2 comma 1. If we check for a reflexive relation, I hope you all understand this R2 is a reflexive relation, because 1 comma 1, 2 comma 2, 3 comma 3. In a set R we have 3 elements 1 2 3, and in a relation R2 also we have 3 ordered pairs 1 comma 1, 2 comma 2, 3 comma 3, which is related to itself. So then R2 is a reflexive relation. By observing a R2 we can find a reflexive or symmetric easily. Okay, so reflexive relation. if we want to check symmetric relation, just neglect these 1 1 2 2 3 3. Obviously if you reverse a 1 1, it becomes 1 1. Obviously if you interchange the 2 2, it becomes a 2 2. If you interchange the 3 3, it becomes a 3 3. Means if A is related to B, then B is related to A, then we call it as a symmetric. Okay, so here 1 comma 1 is related to 1. If we reverse also, it becomes 1 is related to 1. If 2 is related to 2, if we reverse that order pair, we can get 2 is related to itself. So 1 1 2 2 3 3 we can neglect here. Let us check for extra ordered pair. Here is 1 comma 2. 1 comma 2, if we reverse, we get a 2 comma 1. So obviously it is a symmetric relationship, so it satisfies symmetric relation also. Now our main intention is to find a transitive relation. Okay, so previously what we have done for R1, same way we have to do R2 also, but to save time, here we are neglecting these three. Here we are neglecting these three order pairs. We won't focus much on these three order, because 1 comma 1 2 comma 2 3 comma 3 obviously satisfies the definition of a transitive relation. By satisfying a definition of a transitive relation, we can't decide this is a transitive relation, because still there are two order pairs which we have not verified. Still we have not verified for these two order pairs, 1 comma 2 and 2 comma 1. But if we observe in first set R1, so in R1 there is only 1 comma 1 2 comma 2 and 3 comma 3. So 1 comma 1 satisfies the definition of symmetric, and 2 comma 2 satisfies the definition of 1 comma 1 satisfies the definition of transitive relation, 2 comma 2 satisfies the definition of transitive relation, and 3 comma 3 order pair satisfies the definition of transitive relation. So this R1 become a transitive relation. Now we have observed here order pairs which are related to itself obviously satisfies the definition of a transitive relation. So we not focus on here, we won't focus much on this order pairs 1 comma 1 2 comma 2 3 comma 3. If you saw a 1 comma 1 2 comma 2 3 comma 3 or this a relation related to itself in ordered pairs, just neglect those ordered pairs, because we can save time to verify transitive relation or not transitive relation. Okay, so I have neglected this 1 comma 1 2 comma 2 3 comma 3. Now I just focus on remaining ordered pairs. So now I consider 1 comma 2 and we have to find. So now relation is ended with 2 and we have to find pair. We have to find pair which start with 2. We have to find a ordered pair which starts with 2. We have two ordered pairs. One is 2 comma 2 and another one is 2 comma 1. So we have two ordered pairs which start with 2. So here 2. So I already told, so please neglect this ordered pair 2 comma 2. If you got pair in 2 comma 2, neglect it. Okay, so because this is not important here, because if we consider 2 comma 2, obviously we can get a answer here. So we are neglecting this 1 comma 1 2 comma 2 3 comma 3 just for the sake to define transitive relation or not transitive relation. So our main focus is other than these order pairs. So 1 comma 2 I have considered. I am checking here, I am finding here a pair which starts with 2. So if we neglect this part, we have only one order pair 2 comma 1. So here I am going to write order pair 2 comma 1. These both are belongs to R2. Okay, 1 comma 2 is also belongs to R2 and 2 comma 1 is also belongs to R2. So this 1 comma 2 and order pair 2 comma 1 belongs to R2. Implies. Next, let us check for first and last. Now we have to connect first and last. So we have first element is 1 and here last element is 1. So neglect this 2, neglect this part, middle part 2, connect the first and last. So because it is a transitive relation, so here first element is 1 and the last element is 1 comma 1. We got 1 comma 1 which is obviously present in R2. By seeing order pair 1 comma 1, we can identify this 1 comma 1 is present in R2, so that we can say which is belongs to R2. This belongs to R2. So now still we can't say it satisfies the definition of transitive relation, and we can't conclude that it is a transitive relation, because before only I said, if you want to say R is a transitive relation, then it definition of transitive relation should satisfy each and every ordered pair. Okay, so I have considered this ordered pair. Now I have to consider this ordered pair 2 comma 1, 2 comma 1, 2 comma 1. So now we have to find a pair which starts with 1. We have to find a pair which starts with 1. Obviously we have already 1 comma 1, then definitely we have ordered pair 1 comma 1. If there is ordered pair 1 comma 1, then definitely it is going to satisfy the transitive definition, because in previous example we have already saw, if order pair is related to itself, then those relation 1 comma 1, 2 comma 2, 3 comma 3, these type of ordered pairs definitely satisfies the transitive relation. So if we take 1 comma 1 also here, 2 comma 1, so first and last, if we compare first and last, so in first element we have 2 and last element we have 1. 2 comma 1 is also present here, 2 comma 1 is also present in R2, so which is belongs to R2. Now we have verified for each and every ordered pair in R2, but you may ask, we have not verified, still we have not verified for 1 comma 1, 2 comma 2, 3 comma 3, but we have to understand, we have to know ourselves, this 1 comma 1, 2 comma 2, 3 comma 3, those all satisfies the definition of a transitive relation. So to save the time, we are here neglecting 1 comma 1, 2 comma 2, 3 comma 3. Just we verified 1 comma 2 and 2 comma 1. These both ordered pair satisfies the definition of a transitive relation. So we can say this R2. Therefore we can say this R2 is transitive relation. This R2 is transitive relation. I hope you have understood the example R1 and R2. Now let's see another example. So I am trying here R3. Okay, so this last example for a transitive relation. So 1 comma 1, 2 comma 2, 1 comma 2 and 2 comma 3. So now I have considered 1 comma 1, 2 comma 2, 1 comma 2, 2 comma 3. By observing this R3, we can definitely we can say this R3 is not a symmetric relation, because here 3 comma 3 is missing. Here we have 1 comma 1 and 2 comma 2, but there is no 3 comma 3. So we can say this R3 is not a reflexive relation. When it comes to symmetric, so 1 comma 1, if we reverse the 1 comma 1, obviously we get a 1 comma 1 itself. If we reverse the 2 comma 2, obviously we get a 2 comma 2 itself. If we reverse this 1 comma 2, 1 comma 2 is present in R3. If we reverse this 1 comma 2, 2 comma 1 is not present in R3, then we can say this R3 is a not symmetric relation. Okay, so finding a reflexive and symmetric is very easy, but when it comes to transitive, we have to verify each and every ordered pair if satisfying the definition or not. So now 1 comma 1, 2 comma 2, I just neglect this part here. I neglect this part because already I have said why I am neglecting means 1 comma 1, 2 comma 2, 3 comma 3, like these which are related to themselves obviously satisfies the definition of a transitive relation. So for the saving time, we are neglecting this 1 comma 1, 2 comma 2. Just to focus on 1 comma 2 and 2 comma 3 here. So I considering 1 comma 2 and find the pair which starts with 2. Find the pair which starts with 2 in relation R3 itself. So in relation R3 starts with 2, here is 2 comma 2. So I told we have already neglected, so I am not focusing on this 2 comma 2. So another I am finding a relation which starts with 2 means here we have 2 comma 3. Here we have a 2 comma 3. So now I am considering this 2 comma 3. These both are present in R3. So I have written 1 comma 2 and 2 comma 3 belongs to R3 here. So implies, see now implies, or we can use the word but, anything. So if we use, so but first element is 1, so I am writing it as 1, and connect this first element to last element. This is nothing but a 3. This is nothing but a 3, 1 comma 3. But if you verify in R3, there is no 1 comma 3. There is no ordered pair 1 comma 3 in R3. So we can say, or we can conclude, this 1 comma 3 which does not belongs to R3. 1 comma 3 is not belongs to R3. If you got any one this type of order pair which are not present in R3, then definitely we can conclude R3 is not transitive. R3 is not a transitive relation. R3 is not a transitive relation. I hope you all understand this not a transitive relation also. So when it will become not a transitive means, so both ordered pairs are exist, 1 comma 2 and 2 comma 3 pair is present. But when we compare the relation from first and last 1 comma 3 which is not present in R3, then we say that it is not transitive. To say not transitive, if we found any one order pair which is not belongs to relation R, then definitely we can write it is a not transitive. There is no need to verify for other ordered pairs. If we found any one ordered pair which is not satisfying the definition of a transitive relation, then definitely we can say it is a not transitive. But when you got a ordered pair which satisfies the definition of a transitive relation, still should not conclude that it is a transitive relation. We have to verify that definition for each and every ordered pair. If after completion of verifying each and every ordered pair, if there is every ordered pair which satisfies the definition of transitive relation, then definitely we can conclude that it is a transitive relation. If we found any one ordered pair which is not belongs to R3, it means A comma B. Here A comma B belongs to R, B comma C belongs to R, but A comma C does not belongs to R. So if you found any one order pair like this, then we call it as a not transitive. Then we can conclude it as a not transitive. I hope you have understood how given relation R satisfies the definition of transitive relation, and how given example is satisfies the definition of not transitive. Okay, so there is one confusion part here is, so let's move to that part here. So this transitive relation example for another definition. In previous video I have mentioned another definition also. If you not watched, please check my description. I have mentioned that previous video. Please go and watch that video. Then definitely you are going to understand this definition also. Based on this definition, now I am going to explain the examples, so that by observing the example we can say transitive relation with the help of this definition, because this is the confusion part in the definition of a transitive relation, and most of the textbooks has not mentioned this definition. Why, I don't know. Let's understand this let's understand this transitive relation part with this example. Okay, so same set I consider here 1 2 3 1 2 3. Let's take R2. So I am considering R2 relation. See, only one order pair I am taking, 2 comma 3. So in MCQ questions also they will ask like this type of question only. They give a relation to each order per 2 comma 3, and they give a 4 options: reflexive, symmetric, not reflexive, not symmetric, transitive, not transitive. Like that they create a 4 options. We have to pick which option is right for this relation R. So let's check for the reflexive. So for to satisfy reflexive, there should be a 1 comma 1 2 comma 2 3 comma 3. There is no 1 comma 1 2 comma 2 3 comma 3 here. So 1 comma 1 does not belongs to R2, means here R2 is not not reflexive. You can say it is not reflexive. So if you take 2 comma 3 which is belongs to R2, but if I reverse this ordered pair 3 comma 2 which is not belongs to R2, then this R2 is not symmetric. Then this R2 is not symmetric. See, now let's check for transitive. So here only 2 comma 3 is present, so ordered pair 2 comma 3. And if you verify, if you check ordered pair from 3, if you find the ordered pair which starts with p, there is no pair, we won't get any pair in R2 because there is only one ordered pair 2 comma 3. So it started with relation 2 and it ended with relation 3, and there is no relation which is starting from 3. It means there is no ordered pair which starts with 3. If there is no ordered pair, if there is no pair for this particular 2 comma 3, then we should say this is transitive relation. Then we should say it is transitive relation. It means, so 2 comma 3 is present, but 3 comma something, this something I am writing showing it as a box. So 2 comma 3 is present in R2. This 3 comma some element is not present in R2, then we cannot say, we can't decide this 2 and this box 2 comma this box which is not in R2. We can't decide or we can't prove this 2 comma something is not belongs to R2. Then obviously we have to accept it as a transitive relation, because we are not here in this example, it is not possible for us to prove it is a not transitive. When for us it is not possible to prove not transitive, then we have to accept it as a transitive relation. So this is the vastly true condition. When we can't prove a wrong, we have to accept it as a true. When we can't prove it is a false, we have to accept it as a true. In same way, when we can't prove it as a negative, then we have to accept it as a positive. So in same way, when we are in this example, in this particular example R2, we are not possible to say it is a not a transitive, then definitely we have to accept it as a transitive. Means when they, in simple way, if you take a ordered pair a comma b, and if you search for b comma c in R, if you not found any pair for a comma b, then definitely it is a transitive. If you not getting a pair for a comma b, which is nothing but b comma c, if you not getting a b comma c, then we can't conclude about a comma c, then we have to accept that relation is a transitive relation. I hope you all understood the definition of a transitive relation, and as well as these examples of a transitive relation. So I hope you all understood the symmetric relation, reflexive relation, transitive relation. In next videos, I am going to explain about these three, combining these three types of relation. We are going to solve some problems. So those problems are important for your PU board. So you can expect 3 marks from this type of relation. We have to prove reflexive relation, we have to prove their transitive relation and a symmetric relation to get a 3 marks. They give a one question relation, or we have to prove or show that given relation R is a reflexive, symmetric, transitive, or not reflexive, not transitive, not symmetric. Like that we have to find the types of a relation for given R. So while explaining those problems, definitely if you have any doubt, you are going to clear in those upcoming videos. So stay tuned and watch my videos. If you not watched my any previous videos, definitely you can check my description and you will get all my previous videos. Watch with series. I have mentioned episode 1, episode 2, episode 3, like that. So watch those all episodes, then definitely you are going to learn slowly one by one. And after completion of all those videos, next video I am going to explain a problem. After watching these videos, if you watch that problem, then definitely those problems will be easy for you guys. So you can get 3 marks very easily from these type of relation, just by understanding a reflexive relation, symmetric relation, transitive relation. So we can get a 3 marks in PU board, as well as we can score well in a KCET level also. Okay, so let's meet you all guys in next video. Okay, bye.